Today we are going to solve question number 2 of real numbers exercise 1.1. So the question says, show that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5 where q is some integer. So before we begin with the question, let us see the two most important thing in this question. First is positive odd integer. We need to remember that here whatever we will consider should be a positive integer. As in real numbers, we have discussed that various numbers that we see are all real numbers. So here we have to only consider the positive odd integers. The second thing is that it is in the form of 6q plus 1 or these. So just by seeing, it should click in our mind that this is of the equation that we have already studied in our previous videos about the Euclid's division algorithm. So what was the equation? It was A is equals to BQ plus R, where the given condition was that R should be greater than or equal to 0 and should be less than B. Here, by comparing the equation, we can see that B can be replaced by the value 6, or we can say that the value given for B is 6, because in each and every equation, in place of B, it is the 6 that is being repeated. So we can have some assumptions from the question itself that B is equals to 6. Now when we look at the condition given here, so we can say that R needs to be in a range of 0 to a number less than B. So as the number given is 6, we can reduce that R can be either 0 or it can be 1 or 2 or 3 or 4 or it can be 5, a number less than 6 ranging from 0 to 5. Now let us start solving the question. As we are given BQ plus R form, so let us assume let A be any positive integer. So we'll write it like this: let A be any positive integer. Let A be any positive integer and B is equals to 6 as given by the question itself. Now using Euclid's division algorithm, now substituting the values of R in the given equation of Euclid's division algorithm, let us see what we'll get. First, A equals to 6q will replace B as 6 plus R. The first value of R will take it as 0. Now anything plus 0 will give that number itself and that will be given to A. Okay, so let us now understand that if we multiply any given number, any integer with 6, what will it result? So if we write the multiplication table of 6, we'll see that 6 1 6, 6 2 it's 12, 18, 24 and so on. So it will always give a positive integer. So anything multiplied with 6 will always give a positive integer number, and hence A will result in a even number. It will result in a even integer. Likewise, we will do for the rest of values. A equals to 6q plus 1. Now, if we add 1 with 6, it will give us 7. If we add 1 with 12, it will give 13, and likewise. So it will always result in a odd integer. Odd integer. When we talk about the third value, it is A equals to 6q plus 2. Now anything added with 6, 2 added with 6 will always result in a positive integer. So I mean even integer. So it will be a even integer. Okay, now next value, it is 6q plus 3. This will again result in a odd. 6 plus 3 is 9. Okay, so it is again odd integer. This is A equals to, and then again it is A equals to 6q plus 5, and this will again result in a odd integer. Hence we saw that therefore we can deduce as 6q plus 1, 6q plus 3, 6q plus 5. These are the three equations that will result in a positive odd integer, and hence this is the answer.